This problem is number 30 from the 2013 Mock Math Counts Sprint Round, number 2. And this is an interesting problem because it uses 3 or 4 different nice geometric theorems to get to a solution. And there are also a couple different ways to do it. The first thing is, we've got this kite that has length 6 and 6 and length 12 and 12. And then it asks you to find the area of the rectangle if you connect up midpoints. Well, whenever you connect up midpoints, you've got to think about what you're creating. And in this case, what's actually happening is, if you kind of look closely, since these are midpoints, then that means that this triangle right here and that triangle right there are going to have be similar to each other, and they're going to have the same base. And so it actually turns out when you fold them over, kind of like this, and then this one down, they fill in that that little square I just drew. And you can continue to do this, and you actually find out that this rectangle is equal to exactly half the area of the kite. And so this problem becomes a kite problem, in that all you have to do is find the area of the kite, and then you divide it by 2, and that gives you the area of the rectangle. And so now you've got to think about, what do I know about this problem that will allow me to solve it? Well, you're given that this is 6, and then it tells you that this long diagonal is 16. And you might be tempted to go through and find this short diagonal, because there's this nice formula that says 1/2 d1 times d2, and that's a very nice way to go about doing this problem, except that you get to some pretty messy algebra, because you've got to go through and do a 2-variable equation and 2 separate equations, and it's a very messy problem to go about doing that way. The much easier way is to realize that in a kite, this triangle is equal to this triangle. And so this triangle is exactly half the area of the kite, and that's what we're trying to find out. The rectangle is exactly half the area of the kite, so all we need to do is find the area of this triangle, so we can use Heron's formula. And if you remember Heron's formula, that it is the semi-perimeter, which is half the perimeter, which for this problem turns out to be 17. And if you want to know the area of a triangle, you just do the semi-perimeter times the semi-perimeter minus each side. 17 minus 16 is 1, 17 minus 12 is 5, and 17 minus 6 is 11. So the area of this triangle is just 17 times 5 times 11, which turns out to be 935. Based on the fact that each of these are prime numbers, you can't simplify it. So the area of this rectangle that we're describing is just square root 935. Like I said, it was definitely a complicated problem because of the different theorems you had to know, particularly knowing that the rectangle is half the area of the kite. But after that, the calculations weren't all that difficult, and it was very easy to come to a quick solution of square root of 935.